Okay, we're going to look at ellipses in this video. First of all, the definition of an ellipse is a set of all points x, y in a plane, the sum of whose distance from two distinct fixed points, called foci, is a constant. Foci is the plural of focus. So in this case, let's say that d1 plus d2 is 10. Let's say it's 10 centimeters. That means for any other point, I can pick this point right here, and I can connect that point to each of the two foci. The distance here, I'll call it D3 and D4 just to make it different, but in this case D3 plus D4 would also equal 10 centimeters. So it doesn't matter where you are. It's like you take a string and you put a pencil right here at the dot, and you just kind of rotate it all the way around. You will get a set of points such that the sum of the distance from the foci to any point on the ellipse is the same number. In this case it would be like 10. So kind of just remember the picture that I did in class where I taped the two ends of the string onto the blackboard and drew the ellipse. Now let's look at the parts of the ellipse. Okay, an ellipse can be wide or it can be tall. It will always have two focus points, and the focus points will always be on the longer axis. You've got a major axis, which is the longest one, and you've got a minor axis, which is the shorter one. Now, you do have a center. You have what we call a vertex at the end of the major axis. You've got another vertex at the end of this major axis, and these are called covertices. Those aren't as important of terms as major axis, minor axis, and focus. But let's take a look at a couple other pieces here. Okay, there are a couple of important, three to be exact, three important numbers that you need to consider. The distance from the center out to the vertex, that's the long distance, is what we call A. The shorter distance we call B, and the distance from the center to the focus is always called C. Now, there is a relationship between A, B, and C. It's kind of like a Pythagorean relationship, and so having said that, the way to remember it is to just look at your picture and look for the biggest number. In this case it's A squared, or it's A, so our relationship is A squared equals B squared plus C squared. Or if I want to solve it for C squared, I can say C squared equals A squared minus B squared. Okay, now let's take a look at a vertical ellipse. A vertical ellipse is just one that's taller than it is wide. I'm still going to call the longest distance A, the shorter distance B, and the distance to the focus is C. So again, I still have A squared equals B squared plus C squared. Okay, here's the standard equation of an ellipse. If the center is HK, here's our HK, we are going to have the H with the X and the K with the Y. Now remember that if it's in the parentheses, we're picking out the center, we're going to be looking at the opposite of what we see in here. Now, this has the A squared listed under the X. This one has the A squared listed under the Y. The difference between the two is they are considering the major axis as being the A value that we have A squared here for. So if the larger number is under the X squared stuff, then the ellipse is going to be shaped like this. If the larger number is under the y, then it's going to be shaped like this. That's all that means. Don't get hung up on which one is A and which one is B. What you need to realize is that what is under the x is my x direction. What's underneath my y tells me how far to go in my y direction. So let's look at an example. Okay, let's look at this equation. Since there is no h and k, this one must be centered at the origin. Now, I've got two numbers here. B squared is what we consider the smaller number, and A squared is the larger number. And then that makes B2 and A is 3. But honestly, if you're going to graph this, this is what I want you to do. I want you to look at what's underneath the x. That's a 4. So take the square root of 4, and that's your left and right direction. So you're going to go right 2, left 2. What's underneath the y tells you how far you're going to go in the y direction, which means up and down. Since you have a 9 here, the square root is 3, so we're going to go up 3, down 3. And this is what the graph will look like. Okay, here's the equation again. What I need to do is go left and right 2. So from the center, I'm going to go 2 to the right, 2 to the left. What's underneath the y is a 9, which means I'm going to go up 3 and down 3, and I'm going to draw my ellipse. Now, if you're asked for the coordinates of the two foci, here's one, here's the other. So what are the coordinates of that? Well, your relationship, you need to, you can look at it as a squared equals b squared plus c squared, or what's actually a little bit easier is if I solve this for c squared, I get c squared equals a squared minus b squared. Now remember that a and b squared are these numbers here. So a pretty quick way to go about this is c squared is going to be the difference of these two numbers. Take the largest one minus the smallest one. 9 minus 4 is 5. So that means c squared equals 5, because that's a squared minus b squared. That means c equals the square root of 5. So if you want to write your coordinates over here, this is going to be 0, comma, radical 5, and this is going to be 0, comma, negative radical 5. Now if I have to graph those, I'm going to have to estimate. Those are about, radical 5 is about 2.2, and that's why you see the points here and here. Okay, let's look at another one. Okay, let's look at this example. It says find the standard form of the equation of the ellipse centered at the origin with minor axis of length 8 and the foci are at plus or minus 3, 0. Now the first thing you're going to want to do is you're going to want to sketch a picture of this so you get an idea of what your equation might look like. Okay, take a look at this. I've put on my two foci, 3, 0, negative 3, 0. My minor axis is 8. That means I went up 4 and I went down 4. Now, the longer axis is going to include the two foci. So I know that it's going to come out here somewhere to the right and to the left of my foci. Here's my basic sketch. It always equals 1, and here's my x squared and my y squared. It's centered at the origin, so I know there's no h and k. Now, I know that I went up 4 and down 4. That number, 4, gets squared and becomes a 16 right there. I need to find this guy right here. Now, to find that, remember that the focus distance, which I know is 3, that has a relationship with the 4 and with my longer distance a. So I know that my longest distance is a squared, and that's what I'm trying to find. That has to equal b squared plus c squared. B is the shorter distance, so I know that this is 16, and I have c squared. Oh, but I know what c is. That was given to me as being 3, so 3 squared is 9. So a squared equals 25, which means a is 5. So when I go to graph it, I need to know a is 5 so that I know to go out to this point and to this point. I need to have a squared, so I know to put a 25 right here. So this is my equation, and if I were going to graph that, I would have to carefully sketch my ellipse. Kind of hard to do on the computer, but it would look something like that. Okay, here's a little bit better picture of that ellipse. Here is my distance. I went up 4, down 4. Here are my two foci points, right 3, left 3, and right 5, left 5. Okay, I'm going to sketch the graph of this equation. Now you'll notice that is not in the right format. So I'm going to kind of follow what I did when I started doing the circle. I'm going to group things. Okay, what I've done is I grouped the x terms and the y terms. I put the blanks in on both sides. Now, I can go ahead and put these in parentheses because this has a 1 in front of it. But there's a problem here. I've got a 4 here and I cannot complete the square as it is. I mean, I have my parentheses here, but I can't complete the square. I can go ahead and complete the square with this one. Take half of 6 is 3, squared is 9. So this becomes a 9, and this is a 9. But before I can go any further, I'm going to have to factor out this 4. So I'm going to write plus 4, and then in parentheses I will write y squared minus 2y plus blank. Now on the other side, so far, if I put these together, that's 0, but I still have my other blank. So let's keep going. If I take half of this and square it, that's a 1. But remember, what I really did on this side of the equation is I have 4 times 1. So I have to put a 4 here. So let's clean it all up. Alright, so I've factored each of the trinomials. I still have this 4 here, and I have a 4 on this side. So don't worry about this guy. What you need to worry about is this one, because for an ellipse you must have a 1 there. So I'm going to divide all the way through by 4 for all the terms. What happens is these two 4's cancel, and I have a 1 left. And this over here simplifies to a 1. So here's my final equation. Here's my final equation. You can see here that the center of this ellipse is going to be at negative 3, comma 1. Negative 3, comma 1. I'm going to go 2 units right, 2 units left, 1 unit up, 1 unit down. So let's take a look and see what that looks like. Alright, here's my equation again. My center is at negative 3, comma 1. So negative 3, comma 1 is right here. This tells me to go right and left 2 units, so right and left 2, and the square root of 1 is 1, so I go up 1, down 1, and draw my ellipse.